Edexcel IAL Chemistry 2025 June, Unit 1, Question 21. This question is about ionization energy. Write the equation for the third ionization energy of calcium. So, third ionization means you have to start with calcium 2 plus, including symbols. You have to give the equation. So, calcium 2 plus in gaseous phase gives calcium 3 plus plus electron. The following data show the first 7 ionization energies of an element in period 3. Deduce with a reason the identity of the element. You can see a big jump between 6th and 7th ionization energy. So you can imagine that you can deduce that this atom is containing 6 electrons in the outermost shell. So sixth group, period 3, is sulfur. State the general trend in first ionization energies across period 3. Generally, you can see an increase, though there are fluctuations. Plot the following first ionization energies of the elements in period 2 on the grid below. So, you have to make the plot. No need to use the lines to join the plots. Just this will score the full marks. Never use trend lines. Explain the difference in first ionization energies between beryllium and boron. Beryllium is group 2, boron is group 3. First ionization of beryllium involves removing an electron from the s shell, which is more shielded, which is less shielded than the p orbital. So the when it comes to boron, the uh, removing of an electron is easier compared to beryllium. Therefore the uh, beryllium electron is removed from 2s orbital, it is difficult than removing 2p orbital, since uh, uh, the 2s orbitals are less shielded, no more effect from the nucleus. Therefore, even the nuclear charge is higher, the first ionization becomes low when it comes to beryllium, when it comes to boron. Explain the difference in first ionization energies between carbon and nitrogen. When you go from carbon to nitrogen, the nuclear charge is increasing by 1. So even though both the electrons are removed from 2b orbitals, the same shielding is there, but the nuclear charge is increasing. Therefore, the first ionization is increasing in nitrogen. You can't address the point, any other points like uh, electron doubling effect. Question 22. This question is about alkanes and halogens. Alkanes can react with halogens to form halogenoalkanes. Name the type and mechanism for the reaction between halogen and alkanes, that is a free radical substitution. Chlorine reacts with butane. Give equation for the initiation step. Actually, this question is straight away from your theory. You have to draw it as you learned to produce two Cl dots or Cl free radicals, and the arrows you are using should be half arrows in this fish hook shape. Give an equation for each of the first two propagation steps. First two propagation steps, as you have learned, first propagation step is giving rise to an alkyl radical. Second propagation step should give rise to another chlorine dot chlorine free radical, so the reaction can proceed. Give the equation for the termination step to form an alkane. We have learned several termination steps, but they are specifically requesting the termination step which produces an alkane. Therefore, the possibility is two alkyl radicals fuse to give you an alkane. In this case, two butyl radicals are forming one molecule of octane. Calculate the percentage yield if 1 gram of trichlorobutane is produced from 10 grams of butane using overall equation shown. So you can see butane to chlorobutane ratio is 1 to 1. Percentage yield, we know it is equal to yield divided by theoretical yield into 100. And the amount of butane can be calculated using mass of butane divided by molar mass of butane. Mass of butane is 10 grams. So we will apply the values. Before that, you should understand that this amount of butane is equal to the amount of trichlorobutane expected, the yield. The expected amount of trichlorobutane to be formed according to stoichiometry is equal to amount of butane. It is a 1 to 1 stoichiometric ratio. So apply the values, and uh, using this equation you can get the mass of trichlorobutane expected. Then we will get that you are expecting a mass of 27.844 grams of trichlorobutane, but here in the question it says you are getting only 1 gram. So the percentage yield is 1 gram divided by 27.844 grams into 100. I think you are getting a really big yield of 3.59%. Part D, chlorine can be analyzed in a mass spectrometer. On the grid shown, draw the spectrum you would expect to see for the molecular ion peaks of chlorine molecule Cl2. Isotope abundances are given. So, let's see the possibilities and their ratios. The possibilities are you can get Cl35 Cl35 molecules, and Cl35 Cl37 molecules, and Cl37 to Cl37 and Cl37 molecules. So the ratios can be calculated as x squared to 2x to y squared. Oh, in this expression, the 2 is missing in the middle part. However, we will apply that, and the answer will be, I have used, instead of 75%, I have used 3 divided by 4. So you can do some mental math and quickly do this. So you are getting 3 divided by 4 squared to 2 times 3 divided by 4 times 1 divided by 4. Here 1 divided by 4 squared. So if you simplify this, you are getting the ratio 9 to 6 to 1. So in the grid provided, you have to draw lines at 70, at the mass 70, a line representing number 9, at the mass of 72, 6 squares, at 74, 1 square.